Good morning, everyone. We are from Department of Computer Science and Engineering. Today, we are presenting our major project, Adware. It is an AI explainable based framework for predicting adolescent concern over unhealthy food advertisements. This project is carried out under the guidance of Associate Professor Dr. Johnson Kolyuri. So, first, we would like to start about the introduction of our project. So, the main theme is that adolescents are increasingly exposed to unhealthy food advertisements through digital platforms such as social media, online streaming services. These advertisements can shape dietary awareness and behavior preferences towards the adolescents. So, our system uses machine learning and explainable AI to understand and predict how adolescents react to such advertising exposures. So, if we talk about the problem statement, current research in this domain mainly relies on descriptive statistical analysis. There is a lack of predictive systems that can quantify concern levels and explain influencing behavior factors. Therefore, our aim is to build a transparent and data driven framework that provides both prediction and interpretability. The main objective of our project includes predicting the adolescent concern levels, identifying key influencing features, and supporting ethical decision making through explainable AI. The stakeholders of this project includes adolescents, educators, researchers, policymakers, parents, and also AI developers. So our expected outcomes include improved understanding of advertising influence, reliable prediction insights, enhanced awareness among stockholders, and support for evidence based public health interventions. Our literature review highlights the importance of explainable AI in health related behavioral prediction system. Unlike traditional black box models, explainable frameworks provide interpretable reasoning, which improves accountability and trust in AI driven decisions. So, for this project, we implemented the random forest classifier. It is a supervised ensemble learning algorithm. This model constructs multiple decision trees and combines their outputs to improve accuracy and reduce overfitting. And the sharp explainability technique is integrated to provide feature contribution insights. And the model performance is evaluated using metrics such as accuracy, precision, recall, and F1 score. So these snapshots demonstrate prediction outputs and analytical visualizations generated by the system. They show how behavioral exposure data is processed and how concern levels are categorized. And if we go towards the next slide, it explains result comparison and analysis. This section compares performance trends across different evaluation experiments. Visual graphs also help interpret classification effectiveness and model consistency. And if we go towards the next one, it explains framework overview and prediction interface. The framework overview diagram illustrates the complete workflow, including data processing, model training, evaluation, and explainability integration. And the prediction interface allows users to input behavioral parameters and obtain concern level predictions along with their influencing factor insights. Next, if we talk about dashboard analytics explanation, it visualizes prediction distribution, demographic trends, and advertisement exposure patterns. Here, explainable AI insights provide interpretable feature importance, which supports the data driven awareness planning. And here, the model performance insights compare analysis between model highlights and the differences in their classification accuracy and F1 score. Confusion matrix also helps understand correct predictions and misclassification behavior. The dashboard also supports real-time monitoring of concern level outcomes. And finally, the major challenges faced include the data collection, which included collecting reliable behavioral data, processing heterogeneous datasets, selecting optimal models, and integrating explainability without reducing accuracy and managing time constraints. And the final impact of our results, this project successfully demonstrate predictive modeling of adolescent concern levels. Explainable AI integration ensures transparency and ethical deployment, and the system contributes to public health awareness, research insights, and policy support. And at the last, the future scope. Future enhancements include using larger datasets, implementing deep learning modules, and enabling real-time exposure monitoring, as well as developing mobile or web development platforms and explaining and our expanding our research across different cultural contexts. And that is it. Thank you for. And I would like my friend Sujit to give us the technical representation of our code and the output. Over to you, Sujit.
Yeah, now I will execute the system. Hello everyone, I am Sujit and now I will execute the system to demonstrate the working interface. First of all, let us see the project folder structure. This is my project folder structure. This is the main root folder, Adware project. In this, I have the src.env files, etc. And I also have the backend folder separately, the Flask API calls and everything. This is the app.py file, uh, and this is the generate confusion matrix generating Python code. And here are the all the pickle files which get generated after training the model with the Python code that is random forest and logistic regression. With that, we get the metrics and the output data, the percentages, the F1 score, the recalls, and everything. This is the training model code in which we have the random forest and the logistic regression codes. Uh, this is the these are the codes. Uh, now I'll open the front end codes. Everything. These are the codes. You can see about this is the about dashboard, home, model comparison, model insights, predict results, and the system architecture pages. These are the main web pages we have in this Adware project we included. So now we'll go back to the VS Code. Now you can see here we are at the uh, here in this terminal we are at the root of the project, so that now we'll go to back to the backend folder. The backend folder is present in the root folder, that is the backend is present in Adware project. Now what I'll do is I already trained the train underscore model.py file, and I got these all metrics and the pickle files which contain everything, the precisions and everything, the graphs, and also I have the confusion matrix also, images, and its corresponding codes. Now simply I'll just run Python app.py. Uh, this is the execution. Now it's running in this port 5000. So next, in this terminal, I am presently in the folder Adware project. It is the main root folder. So now I'll run npm run dev. I am starting the server. Now I got the link. So control plus link. Yeah, now I am able to see the project. So this is the project. This is the home page of the project. Uh, Now we can see the basic descriptions of AI, explainable AI, personalized insights, how our project works, the real-time analytics of the project, the data we collect, and how we analyze them, and the working flow of our project, the input data, the AI analysis, and getting results and taking action. Now, when we click upon the start assessment, we defaultly get these values, the age group like this, and the genders, male, female, the screen time, the primary platform, advertisement frequency, advertisement type, advertisement persuasiveness. So defaultly we have this. We'll just edit the default values. So now this is a shape diagram, shapely additive diagram of explainable AI. These are the factors which are influencing the concern level. Now we got the prediction as high concern. The random forest confidence is 60%. Means 60% it's saying is high concern, and the logistic regression confidence is 47.80%. Means it says around 40, with 47 percentage it says high concern. Now these factors coming to this explanation, at this e f of x 0.434, the model started taking the daily screen time as a factor of influencing the concern. Its influence is zero, we can see here. This gender has decreased the concern level with a minus 0.02, and primary platform increased the concern with 0.05, and ad persuasiveness decreased the concern with 0.08, and age group incident increased the concern with 0.09, and ad type decreased the concern with 0.1, and ad frequency increased the concern with 0.23, and finally we got the high concern prediction. Now this is the model insights. Now we can see the F1 random forest accuracy percentage 52 percentage, the random forest F1 score, and logistic regression accuracy and logistic regression F1 score. This is the model comparison. This is a percentage accuracy we got through random forest, and the comparison, see, you can see the difference between the comparison percentages 52.17 and 43.48. This is a random forest confusion matrix after training the model. This is the image of the confusion matrix we got here. Now moving back to the dashboard. Now here we can see the total predictions we have made after starting the server. Since we have made one prediction, it's one. The recent prediction we got just now is a high prediction. Concern class is one because we just got the high concern class after prediction. When we get more classes like medium concern, low concern, the concern classes will be three. So at now present we got just one class that is high concern. So it is one. This is the concern level distribution. This is a high concern one. It's a pie chart, and we have the bar graphs. So the platform exposure analytics, Instagram. That's multiple platforms, the TV and YouTube. Now we go to the about page, and here this is the clean description of our product, the research motivation and objective, behavior machine learning pipeline, and explainable AI interpretability layer, comparative model selection strategy, how we selected the model, and responsible and ethical AI considerations. Uh, what we try to do is we use the ethical AI so that everyone can use that safely. With more privacy concerns, we develop this. Uh, Now, my friend Jafar will ask the questions to Janardhan Rao about our project. Uh, uh, Jafar, please take over.
and analytics component.
So, what are the future enhancements or the scalability possibilities of the project?
So future enhancements of the Adware project is include integrating larger multi-platform datasets, implementing deep learning models for improved prediction accuracy, and enabling real-time ads,